Hi friends, welcome to my channel. In today's class, we will do this curve. This curve name is called superior epitrochoid. Here for getting the clear view in the camera, I am using different colors. But in engineering drawing, all diagrams should be with pencil only. Okay. In the daily practice engineering drawing sheets as well as in engineering exam sheets, only use pencils instead of using different colors. Okay. Let us do this diagram. In last few classes, we are discussing about trochoids. So we have discussed about inferior trochoid, superior trochoid. Trochoid means it is the path of one P point. Okay, this is the path of the taken P point. So here where is P point is important. Inferior trochoid, P is inside the circle. In superior trochoid, P is outside the circle. In today's class, we are discussing about superior epitrochoid. In superior epitrochoid, superior means P point is outside the circle. Okay, P point is outside the circle. So superior we are calling. Epitrochoid means this circle is rolling. Let us take in this direction. Okay, it is rolling on this curved surface. This is the curved surface. So this circle is rolling in this direction. Okay. Now this curve is the path of P. Okay, if you are joining all P points, you will get this curve. This curve name is called superior epitrochoid. We will do this diagram by taking the given data. So here I am taking one example. This circle I am taking, this is the smaller circle. I am taking P point outside the circle. Okay, just now I told we are taking P point outside the circle. Okay, if you are keeping this circle like this, if you are keeping the circle like this, so this is the P point. Okay, let us do this diagram. Let us take the given data. After that we will do the diagram. Here a circle of diameter 50 mm. The diameter of the circle is 50 mm. I am taking it is 50 mm or 5 centimeter. What is the radius of it? Half in it, 2.5 centimeters. Rolls outside a circular arc of radius 90 mm. So this smaller circle is rolling on the circular arc. What is the radius of this arc? It is 90 mm. If you are taking roughly here diagram, this is a bigger arc. Okay, the bigger arc radius is 90 mm. Take any one of the point as center. So this is the arc. Okay, so how much radius it is? 90 mm. Okay, this is 90, this is 90. On it, this circle is rolling. Okay, extend this and keep the smaller circle here. Just roughly I am doing here like this. Okay, this is the center of the smaller circle. Let us take like this. Okay, this circle is rolling on this bigger arc. Okay, so it is rolling. Let us take it is rolling clockwise in this direction for one revolution. So it is moving from, let us take this is the A point, starting point. Again this starting point is coming here. Okay, after rolling. So the position of this circle, just roughly I am taking here. Now this is the starting point of A. After it is rolling like this in this direction. Again this A point is coming here. Okay, let us take, we can take A point or B point, it is our wish. So same point is coming here. So same position is coming here. So we can say this circle is rolling one complete revolution. Full stop. Draw the locus of a point. We can take any point here. The name of the point is I am taking capital P point. Lying at a distance of 36 mm from the center of the circle. Okay, from the center of the circle, that point is 3.6 centimeters. Now as you know, this is 25 mm radius. Okay, 36 mm is that point may be coming some distance. Let us take this distance is 36 mm or 3.6 centimeters. Okay, I am taking this is a P point. So this is the position of the given arrangement. Draw the locus of a point P. We need to draw the path of P when the circle is rolling on this curved surface. Now let us do this arrangement practically. Take the bigger curve, okay, bigger arc on which this smaller circle with P point is rolling. Okay, I am taking this is a bigger circle, bigger arc, and this is a smaller circle. I am taking P point outside the circle. Okay, now this circle, take the starting point A point. Okay, now let us assume this circle is starting here. Okay, mark the A point. So I am marking on the paper. So let us mark here initial point, capital A point. So I am marking the same point on the paper also. Okay, it is the A point. So startingly it is coming here. Okay, now this circle, mark the P position also. So here I am marking P position, roughly I am doing. Now this circle is rolling on the curved surface. Now mark the P position. Now this is the P, roughly I am marking. Now again this circle is rolling like this. Mark the P position. Now again circle is rolling, mark the P position. Again circle is rolling, mark the P position. Again circle is rolling, mark the P position. Again circle is coming here. So whatever mark I am taking here starting, so it came here. So this is the end point on the curved surface. Okay, so this circle is making one complete revolution. Mark the P position here also. Okay, now I am marking this position on the paper also here. Okay, here I have marked here. Now we need to mark initial P position, final P position also on the papers. Roughly mark in this direction. Okay, maybe it is coming here, this position, and this position it is coming here. Now here these are the P points, but starting P point is here, end P point is here. Do here the curved surface also. Okay, and do the circle also here, starting position of the circle, so that we can understand easily. Roughly I am doing here. Remove this like this. This is the A, this is the B, initial position and last position. Okay, we need to mark all P points. This is P, this is P1, P2. Let us take like this names: P4, P5, P6. Join all these P points by using the freehand curve. P to P1, P1 to P2, P2 to P3, P3 to P4, P4 to P5, and then P5 to P6. So this curve is the path of P point when this circle is rolling on the curved surface for one complete revolution. This name of the curve is called superior EpiTrochoid. Okay, let us do this diagram by using the drawing instruments and taking this data. Let us do this diagram here. Here leave some gap for getting the entire diagram. Take any one of the point as center. Take 9 cm radius. Do this arc by using compass. Now this is the center I am taking. By using compass I am taking 9 cm. O as center. Do an arc up to some length. Okay. So after getting an arc, take any one of the point A at any place. Okay. Now I am taking, this is a A point. Now I am joining OA and extend this line. Okay, after getting this line, mark this point is A. Okay, after that, here we need to do this line. For getting that line, we have one formula. Whatever angle is coming, we can calculate this angle. Theta is equal to 360 into small r by capital R, where small r is the radius of the smaller circle. Capital R means arc, this capital R means it is the radius of the bigger arc. Okay, now substitute these values. 360 into small r means diameter is 50 mm, radius is 25 mm, divided by capital R. Capital R means radius of the bigger one, 90 mm. Let us do this. 9 4 ja 36, 25 4 ja, it is, so 25 4 ja 100 degrees. This angle is 100. Okay, so from this line take 100 degrees by using the protractor, and this line is coincide with the starting line. 100 degrees means this is 90, 100 means it is coming here. Join this point to center and extend up to this. So this angle is 100 degrees. Keep arrows 100 degrees. Now after getting this A point, take this point is B point. After getting B point, mark the center of this smaller circle. From A, how much radius we have to take for this circle? 2.5 centimeter. Okay, on this line, bigger line. By using compass, take 2.5 centimeter radius. A as center. Mark center of the smaller circle. Okay, give this is C. C as center, do one circle with the same radius. Same radius, C as center. Here I am doing one circle. So after doing the circle, extend this diameter, bigger diameter, up to some length, just like this. Okay. Now after getting this circle, mark the P point. From center to P point is 36 mm. It has given here. From center to P point on this line, 3.6 centimeters. So this is the P point. After getting P point, take CP as the radius. Take CP as radius, C as center. Do one more circle here. Like this. Okay, why we are doing circle at the point means, if this smaller circle is rolling, this P point is also rolling. Okay. Now after getting the bigger circle, divide this circle into 12 equal divisions. We can divide into 6 equal divisions or 8 equal divisions, it is our wish. Okay, for dividing this circle into 12 divisions, what is the angle at the center? It is 360 degrees. Okay, we have to divide this 360 degrees into 12 equal divisions. Okay, so how much it is? 30. So each part is 30 degrees. Now divide here. Take, this is the reference line by using protractor. This line is coincide with the bigger diameter. Take 30 degrees each part. From 0 to 30 one part. From 30 to next 30. 30 plus 30 means 60. 60 plus 30 means 90. 90 plus 30 means 120. 120 plus 30 means 150. 150 plus 30 means 180. It is coming on the same line. Now join all these points to the center. Now this is the first point. Join this point to center and extend the line within this circle only. Okay. Extend this side also because circle is symmetrical. Okay. Now next this point to center. Now 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 already we did the diameter initially. Okay, make it dark. After we are dividing into 12 equal divisions, just mark the numbers here. So this is P. Here this point, this first part is 1 here. This is 2. This one is 3, 4, 5, 6, 7, 8, 9, 10, 11. This last P point we can give one more name, 12. P, 12. After dividing into equal number of 12 parts, this side also extend the line. Okay, circle is rolling from this position to this here up to this position. Okay, whatever this length, we have to mark the same length here also. Okay, just extend up to some length. Extending the line, take O as center. From all these points, do an arc. Okay, so O is a common center. For doing arc at 1, take O1 is a radius like this. Okay, do an arc. 1 and 11 are coinciding because circle is symmetrical. So do an arc. Okay. Next, same center. O and 2 is the radius. 2 and 10 are coming on the same arc. If you are doing an arc, both 2 and 10 are coming on the same arc. After 2, take O3 radius. So O3 radius, do an arc. 9 and 3 are coming on the same arc. Okay. Similarly, center is also there. From center also do an arc. OC is the radius. OC is the radius, do an arc. Next, after 3, 4. O4 is the radius. 4 and 8 are coming on the same line. After 4, take 5. O5 is the radius. O5 is the radius, do an arc. 7 and 5 are coming on the same arc. Okay. Now after 5, take 6. O6 is the radius, do an arc. So up to this last line. Okay. Now after getting all the arcs from all the points, from here also, from 12 also do an arc. So same center, O12 radius, do an arc. So here we did the arcs from all the points. These arcs should be up to this last line. Okay, after that, here we have divided this circle into 12 divisions. Okay, here centers. So circle is rolling. When the circle is rolling, let us take here. So initially center is C. When it is rolling here like this, center is moving from C to C1. Again I am taking this here. So again new center is coming, C3. Let us take C3 center like that. So here C4 center, like that. Centers are changing, but all centers are coming on the center arc, which is passing through C here. Okay, so here how many centers are coming? Here we have divided into 12 parts. So on this center arc, 12 equal divisions we have to divide. If you are dividing this circle into 8 parts, means you have to divide this center arc into 8 parts. Okay, here we are taking 12 parts. So we have to take center 1, C1, C2, C3 up to C12. So this length we have to divide into 12 parts. So here what is this angle for all these curves? It is 100 degrees. We have to divide this 100 degrees into 12 equal divisions. 100 divided by 12. By using the calci, we can calculate this. So it is getting 8.33 degrees. Let us take 8.3 degrees. So by using the protractor, we can't measure 8.3. So this is 10. 8 we can measure directly. Okay, 8.3 we can't measure. So what I am taking? I am taking in between 8 and 9. Okay, so mark that angle. It may be 8.4 or 8.5 like that. Between 8 and 9. Okay, this point should coincide with the center, and this line should coincide. This line should coincide with this line. Okay, take approximately between 8 and 9. Okay, it may be 8.4 or 8.5. Now join this point to center, extend up to the surface. This is the surface on which this smaller circle is rolling. Okay, so this is the surface. So up to the surface I did one line. So I am marking this is, let us assume 1 dash. Just do one line here. Initially do one line here. This is the initial point. Okay, now measure this length by using the compass. This angle length. Okay, this angle length we are taking here. So mark that length here. This length, it may be this angle is 8.4 or 8.5 like that. Okay, take the same length, whatever length here. Divide this surface, curved surface, into 12 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12. 12 maybe it is coming out of the diagram. Okay, so here this is the 12th part, it is coming out of the diagram. That's why we have to reduce this length for getting 12 equal divisions. Okay, I am using trial and error method. First initially remove these previous arcs. Okay, I will remove this line also. Redraw this surface again. So on this surface again I am taking the second length. Okay, so take the second length. As I told, it is trial and error method. First, with the first length we didn't get 12 parts. That's why we have reduced the next length. Okay, take the next new length. A as center, divide the surface. This is 1 dash. Okay, take the next center, this one. Second part, third part, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So we are getting one more extra part. Okay, here we are getting more than 12 parts. That's why we have to increase this length. Okay, we have to take the length between these two. So remove these previous arcs. Okay, we have to increase this length for getting 12 equal divisions. What I am taking? I will take the length in between these two. Okay, third attempt it is like this. Okay, okay, we have to take the length between these two. Now take the third length, take this length. Now A as center, first part, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, and this is the 12th one. So exactly we got 12 parts. Okay, with the third attempt we got the 12 equal divisions. That's why this method is called trial and error method. Okay, we have one more method also. We have to bisect this angle. Okay, bisecting means dividing into half, 50 degrees, 50 degrees. Again 50 degrees part we have to bisect. So 25 degrees, 25 degrees. Here also we have to divide 25 degrees, 25 degrees. So like that also we can divide. We can make it into 8 parts, 6 parts like that. Now here I am following the trial and error method. Okay, here we have divided into 12 equal divisions. I will give the names for this intersection points. 1 dash. So this is 2 dash. Also 12 dash comma B. Okay, now our main aim is we need to mark the centers on this center arc. So join O to 1 dash, extend up to center. Extend up to center. So this is C1. After getting this line, join all these points to the center and extend the line up to center arc. So here we have divided this center arc into 12 equal divisions. Mark the centers. This is C1. This is C2. So 3 line, third line it is C3. Fourth line C4. C5. Sixth line C6. C7. C8. C9. C10. C11. This is C12. So we have divided this center arc into 12 equal divisions. So this is initially C. Okay. After that we need to mark the P position. Starting P is here. Okay, already we took. It is P. So the initial position of P point is here. Okay, this is center C. Now the circle is rolling. Okay, center is now C1. We need to mark the P position. Now after that it is moving. Center is C2. P position is here. So P position is changing, but this distance from center to this P point is constant. Okay, how much it is? 36 mm it has given. Now take the same CP distance. Okay, now center is moving C to here C1, from C to C1. Now do an arc on the first curve which is passing through 1. Okay, so on this mark one point. Okay, mark this point is from P to P1. Okay, now center is moving C1 to C2 here. Now do an arc on the second curve which is passing through. Okay, now I am doing here one arc. This intersection point on the second curve is P2. So now P is moving from P1 to P2. Now take the next center, C3 center. Do an arc on the third curve which is passing through 3, this one. Okay, do here one intersection point. This point is from C3 center, it is P3. Next, after C3, C4 center. Do an arc on the fourth curve which is passing through 4, this one. Okay, fourth one. So on the fourth one from C4 center we will get intersection point is P4. Now after C4 take C5 center. Do an arc on the fifth curve which is passing through 5, this one. So from C5 it is, the point is coming P5. After that take the same radius. After C5, C6 center. Do an arc on the sixth curve which is passing through 6. So here we are getting. Okay, now this point, intersection point is P6. Okay, after C6 take C7. Do an arc on the seventh one, 7, 5. So on this curve, on the seventh curve, do it. The intersection point is after P6, P7. Okay, after C7 take C8. Do an arc on the eighth one, 8 and 4. So on this arc. So C8 it is, the point is P8. After C8 take C9. Do an arc on the ninth curve which is passing through 9, this curve. This point is P9. After that take C10 center. Do an arc on the 10th curve which is passing through 10 and 2. Okay, this curve. So here we are getting out of the diagram. Okay, for getting the intersection point we have to extend this 10th arc. Okay, now extend that arc. Take the same radius, O10 radius. Do an arc, extend this arc. Okay, we will get the intersection point here After P9, P10. Okay. After 10th arc, extend this arc also, 11th arc also. Okay, take the same center, 0, 11 radius, extend this 11th arc up to some length. Okay. Now after extending the arcs, take the same CP radius. This is constant. Okay. Now after C10, take C11, 10th one. Do an arc on the 11th curve which is passing through 11. It is also coming out of this diagram. Okay. So already we have extended this curve here. The intersection point is P11. After C11, take C12. Do an arc on the 12th one which is passing through 12. Here it is coming exactly at this point. So the intersection point is P12. Points. Join all the P points by using the freehand curve. Let us try P to P1 here, P1 to P2, P2 to P3, P3 to P4, P4 to P5, P5 to P6, P6 to P7. So after that P7 to P8. So I will do from this direction so that it is easy to get the diagram. So here I will join P12 to P11, P11 to P10, P10 to P9, P9 to P8. Now here P7 to P8. Okay, this is the required curve. This is the path of P point. This curve name is called superior EpiTrochoid. Given surface, okay, curved surface, this surface and the given circle and the required path should be in dark color compared to other lines. After doing the diagram, mark the given dimension. Smaller circle diameter has given, it is 50 mm. Just do the lines, perpendicular lines to this diameter. Here do the line parallel to this diameter. So take diameter symbol 50. After that, this CP distance has given 36. Take any one of the radius here, radius symbol and 36. Okay, keep arrow here and mark this angle. Okay, so this angle we have calculated. So mark the arrows at both sides of this arc like this and write, okay, clearly 100 degrees. After that, here this bigger radius has given, this surface, curved surface and this center radius. How much it is? 9 centimeter. So extend this arc and do the dimensional line for marking the dimension. Okay, like this, and this length has given 90 mm. Okay, just mark 90 and keep the arrows. Okay, this is the method of marking the dimension. The other video lectures of cycloids and trochoids, I give the link in description box. Please check it. If you like this lecture, hit the like button, subscribe my channel and share with your friends. Thank you for watching.